Good evening. I think I've been set up here as the end note for the Cornish Playhouse. Is that correct? That's correct. Yeah.
You are the
So
final
I am
speaker
the
for
final
New Tech
speaker.
Seattle at the Cornish
So
Playhouse.
you can put those little time cards away.
It's okay, man. We got an orchestra down. You can't. They're small. You can't see
Okay.
them.
So suppose you wanted to connect every item in our everyday world to the internet. And I know it's kind of a grand vision, but suppose you really had your heart set on it. And by every item, I mean every item, not just powered electronic devices like your mobile phone or your Fitbit, but every item. Apparel items, pharmaceutical items, pill boxes, packages, every item you wanted to connect it to the internet. And when I say the internet here, I mean the internet writ large, but also intranets, your home network. You want to connect everyday items. Why would you do such a thing? Well, first, the benefit of connecting everyday items is you can find them, you can authenticate them, you can locate them. You can crowdsource item location. You can investigate items. If I got an item connected to the internet and I can get a unique identifier from that item, then I can go to the internet and pull up information about that particular item and determine whether it's genuine or not. Maybe determine where it was last seen or where I last left it. Or maybe if it's in my house and it's networked, I can find out where I left it. Where did I leave my paperback book, or where did I leave my glasses? And kind of in the endpoint, you can inventory every item in your everyday life. So how would you start? Well, you'd list the features you need to build such a system. The features would include, well, it's got to be wireless because I don't want to go around with maybe some sort of a barcode scanner or typing information in about every item. You'd need super low cost because I want to be connecting all these items. And when the items are really small or low cost, for example, apparel items, it need to be a low-cost connection. Small, zero power, fast, reliable, autonomous. You want something that works just without people involved in the loop. You want a unique identifier on every single item, a URL or some other code to identify that item uniquely from all the other items that are in the planet. And you'd want the technology you use to be complementary to your other connections, complementary to Wi-Fi or NFC or Bluetooth. And you'd probably use a radio for some wireless identification. You'd come up with a cool name. Maybe the name would be Rain. And you'd come up with a nice logo, maybe an R inside a cloud. And you'd create some terminology. Terminology might be, you got some items, you can put a tag on those items. You're going to tag those items with a unique identifier. And you're going to wirelessly connect to those items with some sort of a portal to the internet. And you'd have some software on top that takes all this torrent of data and reduces it to the essential information, the identity, location, and authenticity of that item. And you connect it to the internet. Again, internet either being a home network, an intranet, big internet, or anything in between. And you want some product goals for when you did this connection. Product goals, you need some sort of a ability to connect lots of items quickly. You'd want low cost, like I said before. Some reasonable read range, like maybe 10 meters, so that if you had some sort of radio, it can identify all the items in a facility. Maybe you'd have 2 or 3 radios in this building here, and you could identify all the items. You'd want no batteries. Doesn't make sense to have some sort of a battery-powered thing that you're putting on your shirt. Wouldn't be very comfortable. Wouldn't survive the wash. You'd want unlimited life, unique identifier. You'd want the ability to inventory thousands of items per second. And you'd build it. How would you build it? Well, you got to start somewhere. So you build some little integrated circuit that would go on some sort of a label that would go on an item. And have no battery, last forever, unique identifier, and a tag on the item. You'd have some sort of a portal that would talk to those items. In order for this tag to be zero power, you would have to absorb the energy from the radio waves that are coming to it. So you'd have to build some little power harvesting circuitry such that when the portal turns on, talks to the device, and the device sends information back. And there'd be some communication link. And you'd build mobile portals too, some sort of handhelds, and eventually you'd think about putting portals in smartphones. And you'd sell these tags everywhere. You'd put them on medical inventory items, on the syrup cartridges that go in Coke Freestyle machines, on apparel items, on the bag tags, the frequent flyer bag tags for Qantas Airlines, asset management, the marathon bibs, or the lace bibs for race timing. And you'd watch the market grow. Hope to sell billions and billions and billions of these things, billions per year at some point. You'd promote a platform that delivers intelligence about every item in our everyday world. and you'd connect to all of those items. And you'd foster an industry alliance. You came up with that name, RAIN, so you create the RAIN Industry Alliance, whose mission is to enable businesses and consumers to identify, locate, and authenticate items in our everyday world, and whose vision is a future where everyday things are part of a connected world like raindrops to the sea. Impinj and RAIN are creating that vision, creating the physical web. And we already have the Internet of Powered Devices. We all know it, we all have it. We're creating, and they're connected by Wi-Fi, Bluetooth, and NFC, and wired connections. But Impinj and RAIN are creating the Internet of everyday things, all the items I showed you before and more. And they are connected by RAIN. And Impinj is the market leader. We've already sold 10 billion of those little integrated circuits that go on the tags that go on the items. We've sold thousands and thousands of the portals. We've sold more than 1 million radios that go inside the portals. And we've delivered an entire platform that includes the tags, the portals, and the software to take that torrent of data, provide it to networks, and connect every item in our everyday world. And I see a sign, time's up. And I have brought just a little tag that I think, if I can find it in here, oh, there it is. Just to give folks an idea of the size. There's a little tiny tag, would go on an item. It's a typical size. There's smaller ones, there's larger ones. This one would have about a 10-meter read range. So 2 or 3 readers in the ceiling could inventory every item in this room. And it's zero power, unlimited life, lasts forever. And I won't leave my wallet here. So questions, yes? So the question is, can you tell me about the kind of data that you're taking from the items, and when does it stop? So the data that we're taking from the items is really just a unique identifier for that item. So when you go run a marathon, you have a unique identifier that links to your name in the marathon database that allows you to go after the race and pull up the information about how you did on that particular race. But the only information really on the tag, in the vast majority of tags, is just a number. It's just a unique identifier. How that number gets used is basically depends on how the network links that number to other information. Can you hack into the tag and repurpose it? For a beacon, no, because it doesn't transmit. It only responds. So something interrogates it, and the portal interrogates and says, tell me your number, then comes back and says, here's my number. So it's just a unique identifier. Other questions? Yeah.
Is the number hard-coded into the tag, or is it soft-coded?
Is the number hard-coded into the tag? Typically, the number is hard-coded into the tag at the time that you put the tag on the item, because you don't want to be changing the number subsequently. So the tags come unencoded. You put it on an item, for example, an apparel item, let's say a pair of socks that Zara is selling in a store, and you have the identifier for that pair of socks. Zara would use that information for more efficient inventory purposes. You buy the socks, you bring the socks home, and typically you throw away the packaging and the tag gets thrown out at that time. There are applications for laundry where you leave the tag in, but that's typically for uniforms and other things for laundry purposes. Yeah, question in the back.
So there's no sensor involved, right? Like, so it's not how Snoopy was trying to do it.
There is no sensor involved. It is possible to build tags that can sense a little bit of things like some humidity, but in general, the tag is just a unique identifier for the item. Yeah, other question. It responds to a RAIN interrogator, and the key part of tags is that they are relatively promiscuous. So any interrogator can interrogate any particular item. Now, for items that have privacy concerns, there are privacy features built into the tag, so you can either reduce its range or the amount of information it exposes. But the number of applications that really need those privacy protections are fairly small.
For any additional questions, we are going to have all the speakers available to the right of the stage. So let's all again put your hands together for our speakers tonight.